try some examples of the inverse Laplace transform. You are asked to do inverse Laplace transform of these functions. To solve this, you will need to refer to the table of formula for a Laplace transform. Find a solutions which more closely resemble the structures given in the questions, where you need x squared and you need a squared here, and also you need ns. With that, we found the inverse Laplace transform of this formula, which is equals to cos at. You have to compare the structures of the functions side by side. There is a s squared, and the a squared can be represented by 2 squared, and you need an s here. With that, the t can be brought out of the inverse Laplace transform as it is a constant, and now your functions is totally matching the formula. This will give you your cos 2t, and your final solutions will be this. For inverse transform of this, again, you have to refer to the tables of Laplace transform formula. Find the structures which more closely resemble the structure in the questions given. S squared minus a squared, and there is an x on top of the fractions. This is the inverse Laplace transform of cos at. Move the constant 4 out of the Laplace transform. Now your structure of functions perfectly match the questions given, and your final solutions will be 4 cos 4t. Let us try some other example. Inverse Laplace transform of this refers to the table. You obtain this formula. We structure the functions so that it match perfectly with this. You know that your a now will be equals to the square root of t, because the a here needs to be power of 2. And you need an a on top of the fraction here. By having square root of t here, you will need to cancel out the square root of t. And also you need to move this constant 3 out of the functions. That give you this. Now you can convert this inverse Laplace transform into the sine square root t, 7t. Let us try this example. Refers to the tables of formulas of Laplace transform. Find the relevant structures which give you this. Compare the functions. You will need to rewrite the functions so that it matches totally with the formula given here. This leads to a constant number of 4 factorial and 2 out of the function here. Your a now is equals to 3. Your n is equals to 4. And there will be a 4 factorials. Solve this, you will get this. Your a is equals to 3. Your n is equal to 4. Simplify the functions, you get the final solution.